Hey guys, welcome to my YouTube channel again. So this is my second video on the some data science project, and for today I'm going to show you the analysis on the car data, and it's the interesting one data set. And also I'm going to discuss some of the visualizations with the help of Matplotlib and the Seaborn library. So quickly let's jump to the dataset. Let me show you somewhere in my files. Mhm. I have downloaded it only. Here it is. Okay, so it's a CSV file, and probably it has, I guess, 15 columns. Yes, there are 15 columns. I have made them bold, and the rows are total. I guess it's 428 rows in our dataset. So the data consists of the make, the company which is making the car, and it has the Audi, the BMW, Chevrolet, Honda, GMC, Ford. Then the models, what they are making in the models, their type, whether it's a SUV, sedan, sports car, its origin, whether it's originated in Asia or Europe, whether it's a drive, all-wheel drive, its MSRP, their invoices, their engine size, well, whether they are 3.5 cc, 2 cc, 2.4 cc's, the number of cylinders they are using, the horsepower, this average, their average in the city, averages on the highway, their weight, the wheelbase, and the length. So let's quickly upload our dataset into the Jupyter notebook. So simply I'm opening my Jupyter notebook from here. Yes, it's open. Let's upload the dataset. It's a CSV file. Yes, it's done. Hmm. Now go to the new notebook. We can name it a car dataset. Let's quickly import the libraries in the pandas, the matplotlib, and the seaborn. As I'm going to show you some of the visualizations, so that is done with the help of Seaborn and the Matplotlib library. And for the data analysis part, I'm using the Pandas library. So let's import the libraries. It will take some time. So for the Matplotlib, I have give the abbreviation as PLT. For the Seaborn, I have give the abbreviation as SNS, and for the Pandas, I have given the PD. Let's import the file into the Jupyter notebook. So I'm giving a variable, the file will be pandas dot read csv, as mine is a CSV file. So data is successfully uploaded. So these are the columns, and if you want to only to see the column, just write these are the total number of columns. If you want the uh, total number of rows and columns in our data, simply write shape, and if you want the properties of the column, simply write df dot types d types. Okay, so that so the make is into the object, model is an object, origin is object, and the float values are engine size, cylinder, horsepower, weight. Okay, so let's proceed further. Now I want to find the null values in my dataset. It is df dot is there is any null values column and what's their sum. Okay, so there are four null values in each column and there are total six non values in the cylinder column. So to fill the non values, we write the data in which we have stored our dataset variable and just simply copy the name of the column in this column, and we are going to fill it using the cylinder, and we are going to fill it using the mean. So the data can be filled using the three values, the mean, median, and the mode. So for here we are going to use the mean, put the bracket, and write in place to it's done. Let's see, we have see there are zero values in the cylinder column now, none values. And yes, if you want, we can also fill other columns as well. So let's proceed with the make there also need to see that can be okay. So now make is an string type of data, means it's an alphabetical. So machine cannot apply mean and median over this type of data type. So for here I am using the method mode and it's done. And let's quickly do it for the model. Model, I think the N is capital over here. Okay. See, let me show you the error. Can only concatenate string, not integer to string. So for here I am going to write mode as it's a categorical type of data, so it will be applied over here. Mhm. Now let's fill some this integer type of data to write this. Now the mean and median can be applied. Now let's fill the one of the data weight. Okay, I am just writing the weight over here, and I am filling and I am applying median. I will be discussing in detail about the mean median in my further lectures. Right now, my main focus is to know to let you know how can the analysis can be done with the help of Python. And I am and my aim is to give you the simple coding. And let's okay average. Let's do the average column. Let's copy this whole code and proceed with. Let's also fill this with the median. Okay. If now I again see this hexagonal values, see, we have done with cylinders, we have done with city average, we have done with heights. So this is how treatment of missing values can be done in the dataset. Let's proceed further and let's notice the car makes, the count of the car makers. So how many brands, total brands are making the car and what are the numbers in their dataset. Simply write df and we want to find the make dot value counts. I get some issues with the value. Okay, I wrote the wrong spelling. It's value counts. Okay. So the Toyota is making 28 cars as per the dataset. So there are total 28 cars of Toyota, 27 of Chevrolet, 26 of Mercedes-Benz, 23 of Ford, 23 of BMW, followed by the Kia, Jeep, Isuzu, Mini, Hummer. There are many brands. Okay, now I just want to find that mm, the origin of cars. Okay, so origin of cars in Asia and Europe. First of all, let's see how many this these are given. So there are three cities given in the dataset, three countries origin where the cars are originating. It's the Asia region, the US region, and the Europe region. Let's now I want to find out the origin in Asia and Europe markets. Okay, simply write DF. I want to find origin and I want to find in Asia and Europe. So simply write is in, then again the curly bracket and put a square bracket. I want to find in the Asia and let's say I want to find in USA. Okay. So at the last time I also tell you the trick that if you want this type of data to put into the data frame, simply write the value in which you the whole of the data is stored. It's a df, put a square bracket and at the end put the square bracket. So as per our filtering there are 305 rows. Okay. Okay, now I want to find out that how many car weight are more than 4000. So our data, I want to find out the weight. I want that it should be more than the 4000 and put it into the data frame. Simple IDF and this. So there are 103 rows that the as per which the weight is more than 4000. So let's go to the weight column and see here is the column. Here is 4451 4013. That all the values will be more than this 4000. Okay, now I want to just subtract these values from the dataset. So how it can be done? So for that we simply do one thing. We simply put here, simply write df, and we put a this type of sign, and we write df weight. It should be more than 400, 4000, and put this condition into the curly brackets. Okay, see, the values which are more than the 4000 are being removed from the dataset. Okay, now I want to find out the horsepower which is more than the cars which have the horsepower more than this 200. Let me, yeah, here is the horsepower. I'm copying the this column name because so that no error occur from my side, spelling mistakes. More than 2000. Right. So as per my data, there are no which are more than 2000. Okay, let's proceed further. Okay, now I want what I need to do. Let me show you the data again. Simply idea dot head. Now I want to increase this city average by 3, which means in whole of the rows, in all of the columns, in every row, that if there is 17, that should be a 20. For 24, it should be 27, and further. So we apply the lambda function in this, and it will be df city. It should be df dot a apply lambda. For the lambda, we give the variable and we want x should be plus 3. Let's see the data set. We have derived the city, average in the city. See, all the values are increased by the 3. 17, it's become 20, 24 become 27, and further. All the values will be change in the whole of the this. Okay, now let's do some of the visualization, and that's will be an interesting part. Now I want to see the heat map for the missing values in our dataset. So how it can be seen. Okay, so I'm so there is a heat map functionality in the Seaborn. Let me show you the Seaborn, the library which we have imported. It's the import Seaborn as SNS, and we simply write. And let me first of all show you the missing values. We have dot and dot. So here are the missing values in the data. The small missing values, and if I want to see the heat map of it, simply write sns dot heat map, and in the curly bracket simply write df dot the null values, the data and the null values. So here you can see, let me zoom it for your understanding. Okay, so see, as per this diagram, here are the missing values, and see, we have filled the cylinder, so there is a black area over here. We have filled the mpg average in the city, so it's a blank over here. We have also done the filling of this weight, so here there is a blank over here, and the rest are the missing values are This white line shows the missing values in the data set. Okay, so here is the first graph, and it's quite useful. And yes, we can also see the correlation. Okay, so here is the correlation. So with the engine size, as we see correlation cylinders with the horsepower. Okay, more the cylinders, more the horsepower, and the less will be the average on the highways. More will be the weight. Okay, there is a 50% of around correlation with the wheelbase and the length. And let's see for the engine size. If the engine size is more, then the weight will be also more. Okay, the wheelbase will be more, and the length will be around 63. So that, and this can be also seen with the help of this uh, Seaborn library. I guess there is a functionality sns dot. It may be simply write df dot correlation, and if I write the note, no, let's see the changes. What happens after writing a note equal to true? See, the values are filled. So there is a cylinders is a with the cylinder and the engine side there is a 90% correlation, and there for the one cylinder for cylinder. So you can see later. Okay, let's proceed further. Now I want to plot for this uh, invoice. Okay, let's see some of the trend related to the invoice. So simply write plt dot plot and simply write the tf. It will take some time as the I think the values are more in the data. Mhm. What's the issue? Okay, must have not a float. Okay, I think I have to change the data type for this. Let's proceed further. And now let's the see. Okay, Now let's see the count plot for this. Wait a minute, let me see the reference of the data. And now I want to see the make of this, the count plot for the make. I want to see how many companies are there making the number of cars as per our data. So I simply write sns dot k sns dot be like this. My data is in the df and one to me, and my data is df. I think this will work. Okay. So to increase the size of the figure, we simply write. We need to increase the simply write. It can be increased with the help of matplotlib. Simply write plt dot figure in the bracket write fixed size. It should be. I'm putting it at 10 by 10. I think the issue will be. I think I need to increase it more. Okay. Mm, see it clearly. I think go for this. I think it's now clear, and let's put it. That was okay. Let me zoom it for the reference. So Audi is producing around, I think, the 17. The BMW is around the 20, and I think the most are producing the what the mostly are producing most cars are produced by the Toyota, followed by this Chevrolet. So from this is the use of count plot, and I want to bifurcate this data with the this the origin. So we'll simply write, there is a functionality in the Cbon. We simply write hue. Mhm. We simply write hue hue and its origin. So, see the origin, the blue one represent the Asia, orange is Europe, and the green is USA. So as per our this, most of the cars are produced in this Asia, then followed by Europe, no, followed by US, and then in Europe. So these are the type of analysis can be done with the help of this count plot with the Seaborn library. And yes, this result can also be, if I want to see the count plot of this, that the type of vehicles, and I want to see their drivetrain, whether they are all-wheel drive, front-wheel drive, what's the status, and simply one thing, drivetrain. Okay, so let me zoom it. Okay, so I think the most are the sedans, and most sedans are of front-wheel drive as per the data, and then in SUVs. all most are all wheel drive and followed by the front wheel drive. Mhm. So that's the analysis can be done with this data set. And I think we are done with the data set. And so you can try from your side the analysis. Today I have shown you how to do the correlation, how to find the how can you find the correlation, how can you plot a correlation in the heat map, how you can see the count plot and make 2 3 conclusions from the data. So keep practicing it, and I will be covering more tricks and more videos on it so that it can be useful in cracking the job interviews, or it can be submitted as the projects in your schools and colleges. So thank you everyone for watching my lesson. And yes, I am getting some of the comments in my video that you guys need the data set, the CSV file I am using. So uh, I will be dropping the link in from which you can have access to the data, and you guys can practice over it. Okay, so thank you everyone for your precious time. Have a good day. Thanks.